All right, so we're going to take another look at some of these problems. Let's go ahead and try number 2 here. I don't think we'll do all of them. We'll just do a couple more. But it says, number 2, a thrust force of 3 million newtons acts on a jet that has a mass of 22,000 kilograms. What is the acceleration of the jet? So let's go through, and I always highlight. So this is saying a force of 3 million newtons acts on a jet that has a mass of 22,000 kilograms. What's the acceleration? So before we get to the what, let's write down our givens. We know that the force is 3 million. It's a lot of zeros, 6 of them, newtons. A little typo there, well, let's cross out the word car. A thrust force of 3 million newtons acts on a jet. And then the mass is 22,000 kilograms. What is the acceleration? We want the acceleration, so we have to have an equation that has an A, an F, and an M. And look up top here, we're looking for acceleration. A, F, and M would be this one here. So we'll say we want A. So that's just going to be force right here divided by M. So basically, if we want A, we just do F divided by M. So come down here, A is equal to F divided by M. So we'll say A is equal to force, which is 3 million. 1, 2, 3 newtons over 22,000 kilograms. So 3 million, 1, 2, 3, 4, 5, 6 zeros divided by 22,000. So we'll do 3 million divided by 22,000, and that'd be 136. So we'll say A is equal to 136.36 meters per second per second. So this is 136.36 meters per second per second. All right, let's try another one. Let's go down. Let's try our dog equation here. And it's not the dog equation, but let's try number 5 for our weight equation. A dog has a mass of 40 kilograms. On the moon, gravity is 1.64 meters per second per second. So notice last time, gravity on the Earth right here is 9.81, but on the moon it's actually 1/6 as strong. So now they want us to calculate the weight of the dog on the moon. So let's do this. So the mass of the dog is still the same because mass never changes, because it's the quantity of matter or stuff that makes up this dog. And the dog, we're assuming nothing happens to the dog. It's the same dog on Earth as it is on the moon. And then we got a different value for the gravity. Acceleration from gravity on the moon is 1.64 meters per second per second. And we want weight. So we have to have an equation that has a W, an M, and a G, which is our weight equation. So we're going to say W equals mg. So we'll do W, and then we'll do mass is 40 kilograms times 1 meters per second. And 40 times 1.64 equals 65.6 newtons. So on the moon, the dog weighs 65 newtons. On Earth, it weighs 6 times more. It's going to be 392 newtons. The question is, why does the dog weigh less on the moon than on Earth? And it's because the acceleration, the g on the moon, is 1.64 meters per second per second. And that's less than the gravity on Earth, which is 9.81 meters per second per second. So we'll say there's less acceleration from gravity. So you weigh 1/6 as much. Cool? And then I think we'll do one more. Number 9. Think and explain. Please use Newton's second law, F equals ma. It says acceleration means an object is changing its speed or velocity. Explain why it is easier to change a golf ball's velocity than it is to change a car's velocity. Well, F equals ma. And the question is, why is it easier to change a golf ball's velocity? Well, a golf ball has a really small mass, m. So that means it's going to take a smaller force to make it change its velocity. That's why Newton's second law says F equals ma. So if you put a force onto that golf ball, it'll have a pretty big acceleration. But for the car has a really big mass. which means if you put a force onto it, its acceleration is going to be smaller. So it's easier to accelerate the golf ball because the mass is so small. So for number 10, just go ahead and do your best on that one. See if you can connect Newton's laws to your daily life. But we'll stop there for today. Thank you for watching.